I'm going to start recording. Okay, it's recording now, finally. I'm going to share my screen. Okay, so we are going to go over all the questions you guys just asked me about homework. But first, real quick, everybody open up we'll fire up AutoCAD. And then open up the CAD Google Shared Drive. And on there, go to, I just created a folder, the 4.15.20 working files. And go ahead and download all of that because we're going to be using that today. And then while you're in the process of doing that, let's talk about the questions we had on homework. So the first question was, how do you get more than one layer? And so in AutoCAD, if you go open up the layer properties pane, on the home tab, it should be right here. There's a new layer. Now, AutoCAD says this should be Alt-N. Whenever I hit that, it does not create a new layer. So I'm not sure why it says that, but don't believe it. So you can just hit this new layer button and it'll create a new layer and you name it whatever you want. And then you set the properties in this pane. And that's how you create new layers. And then once you've created it, then you just select whatever content you want to go to that layer. And you select that new layer and it'll automatically assign it.
John?
Yeah.
I was wondering how to get on the layout tab.
The layout tab.
On the bottom left. So some layers won't show up. Well, only the base layer shows up for me.
That is weird. Send me your file. Send me your AutoCAD file. It might have to do with it might have to do with the settings on that particular layer. And then the other question somebody had was, do you want it in color? So yeah, your content should be in color. So typically whatever base layer you have, you decide, or whatever, one of your layers is going to be white, right? And that should be probably whatever the most content is in. So a lot of times you'll have that be your hardware modules. So in this case, it would be this IO card right here that I've selected on the screen. That could be your base layer. And you'd also put maybe the diodes and the power supply, all that on the base layer. And then another layer would be for your like positive wires, which I don't have. So you can make your positive wires blue, and then actually, I misspoke. Ooh, that's bad. So these would be your negative wires that I've turned blue, and then this would be your positive wire, and you can just make that green. Now remember, I'm just throwing those on layers to show you what kind of color scheme you could use. Make sure this layer that this wire is assigned to is labeled something like 24 volts plus, right? So that it makes sense that this content would be assigned. But yes, it's best to assign different colors to your different layers just because it makes it easier to track. And I can show you an example of that in a bit. And along that same vein, the border layer, which I think we assigned, maybe we didn't. Oh no, I still have the old border file open. Okay, so that border file that we created before, I would recommend going in, assigning all the content from the border to one layer, and then making that all one color. There's really no reason to have different colors in your border. So does that cover all the questions everybody had on the homework assignment? I'm going to take the ringing silence. Yeah. Okay. So we have a comment here that some layers didn't show up, and then deleted the layout tab and opened a new one. It fixed itself. This is one of the isms of AutoCAD that even if I worked through it and fixed it, I might not be able to tell you what is going on here. So there's all kinds of controls with turning layers on and off and hiding them. That would be my guess as to what is causing the problem of them not being visible in the layout tab, but without poking through it, I can't tell you for sure. But that is definitely one fix, is to just open a new layout tab. And then you can, if it doesn't default in the view you want, you can go in here and you can edit all this. You can edit the window and fix all that up. So that's always a valid option. If you don't want to go through trying to diagnose why it's not showing up on your current layout tab.
Oh, I thought of a question.
Another question.
Homework.
Shoot.
So what color do we make the switches? Like what layer would that go on? That would go on the physical like components layer, right?
Yeah, exactly.
Would the contact points and the connecting line, all of that would be on one layer, like with all the physical components?
Yeah, that's what I would do. And physical components was probably a bad term to use in that homework assignment. What I maybe should have said is hardware modules or something like that. But yeah, I mean, typically this box is the module and these are termination points. And so they're still part of that module. So I would make those all on one layer. And the thing is that this is pretty much up to your discretion. Like I'm not going to tell you, oh, you made a bad choice of layer assignment and what to assign to what layer. I just want you to play with it, because this is the kind of thing that's going to be set in some standard by a CAD department. It's not like there's a right and wrong answer that's ubiquitous. So it's really totally up to your discretion. Just be thinking about, if I'm making a huge set of drawings and I want to be systematic about how I'm assigning layers, what makes sense and what makes sense to you, and then just be consistent. And if you're running a CAD department, write it down so that everybody else knows why they have to follow that. Because if you don't have your standards written down, it gets really frustrating trying to keep everybody following them. Matthew has a comment here. Got it to work. Just turn on off every setting in the layer properties and regenerate the layout. Yeah, that's kind of like rebooting your computer. Who knows what the problem was, but that'll definitely fix it. Did I tell you guys about the regen command? Well, if I haven't before, I'm going to now. So there's a command in AutoCAD, regen, R-E-G-E-N. If you are ever having problems with scaling or anything, like if you zoom way out or zoom way in and then draw a bunch of stuff and then it gets stuck and won't let you zoom back out, just type regen. It regenerates the model and rescales it. You might encounter that at some point if you're working in a big drawing and doing a bunch of detailed work while zoomed in. So does everybody have the files downloaded from that folder? I'm gonna take the thunder silence as a yes. Okay. I gotta close some stuff. Okay, so I'm gonna open this drawing border to make sure I'm on the same page as you guys. Cool. Okay, so this is the drawing we did last week. You should have something along these lines available to you. We're gonna work on that, but first, I want you to open up. There's these 542 MPL sys drawings. Open up drawing 8, 9, and 10, and I want to talk through these real quick. I'm assuming it's going to take you guys a minute to get those loaded up. Sorry. Dude, this quarantine thing is not good for me. I do not keep a regular schedule when I don't have to. I'm skipping a guest lecture for senior design. Okay, so go to drawing 8 and go to the model space just because it's easier to see. And if you'll notice, on the layout space, it's only showing this power distribution section, but in the model space, there's more drawing over here, right, with this table in it. This is common, and this is something we're going to do today, where you'll create multiple drawings in the same model space because it makes it easier to work on them in tandem. And then when you're done, you'll split the content out into 2 different files, and then forget to update or forget to get rid of this file or this content in your drawing. So ignore this table for now. And if you zoom in here, so this is a power distribution drawing. This is kind of like what I drew by hand in the first circuits series, where I was talking about how you would symbolically draw power coming out of the wall. And so we're not even showing a plug or anything here. We're just showing there's a neutral leg, and there's a live leg, and there's a ground leg. And it's all coming from customer supplied 120 volt AC, 20 amps with a ground, and then the feed panel location. And so for this particular drawing, this is for.
So
Welcome
I'm
back.
the host now. What do I
Hey,
do?
sorry about that. I don't know what's going on with my internet. Hopefully the recording doesn't get totally screwed up by that.
Josh, I'm the host again.
You're the host?
I think Josh is.
How do I stop being the host?
You have to right click his video and then press make host.
John's host on my screen.
Okay. I guess he's good then when he came
Hey,
back.
guys. Yeah. I think because I hosted the meeting, I should automatically host. I hope. Okay. So, what was the last thing you guys heard before I dramatically abandoned you? Don't everybody speak up at once.
I'm still trying to get the files open.
Oh, really?
Yeah, me too.
Okay.
It's not wanting to open any of them.
You just started
Oh,
talking
interesting.
through I think number 8.
Okay.
File number, yeah. And then
Okay.
you just froze.
And then I just froze and disappeared. That's a bummer about the files. Hopefully, there's no reason they shouldn't open for you. It is trying to open them in AutoCAD, right?
Yeah, it says that like the files don't exist, and it says to verify that they do exist, and they do exist. It's
Oh, crap. Okay. That's obnoxious.
Is there a way to open them in your drawing, or do you have to go to the directory?
I don't understand your question.
Like, is there a way to have your current drawing up and then open the files from there, or do I have to like go where I downloaded them and open them that way?
Yeah. So, when you guys downloaded them, did they download as a zip folder?
Yeah.
Yes.
Yes.
Okay. Copy them into a new folder. It won't open files out of a zip folder.
That makes sense.
Yeah. Yeah, I didn't think about that. Yeah, so just make a new folder. That should work. And then as far as opening, yeah, you don't have to navigate to the file. You can, in the top left corner, you can hit open folder, and then it opens up a like old school file tree that looks like it's from Windows 95. And you can navigate to the file you want to get from there if you know the location.
Upper left, you say?
Yeah, upper left, there's the AutoCAD drop down, and then there's new, and then there's open. There.
Oh, yeah, it is Windows 95.
Sorry, what was that?
It does look like Windows 95.
Yeah, I told you this software's old.
But this is the
Oh, wow.
2021 version.
Yeah, I don't know why they didn't update that, but apparently it's not necessary. It's perfectly sufficient for your needs, and you'll live with it. Did you say it's 2021 version?
Yeah, that's what mine says.
Mine says that too.
Interesting.
Ooh, yeah. I'm
oldest
getting
one.
the verify that file exists.
Okay, and you copied it into a. Wait.
Oh, wait, something happened. Yeah, I unzipped the files.
Okay.
Houston, we're getting something.
When it asks you to verify the files, did it show a file extension, like a .bak?
No.
I got
Oh,
it.
there we go. You got to open them one at a time. I was trying to open them all at once.
Oh, okay.
I
Yeah.
got one open. You wanted 6, 7, 8, right?
8, 9, 10. There's so many weird things that cause AutoCAD to just pitch a fit, and I've never had that happen before, but it may be because you're opening the files for the first time and it's from an untrustworthy source or something. I have no idea. But yeah, welcome to AutoCAD. It does weird stuff all the time, and stuff that should work doesn't want to. I don't know. Sue me. Okay. So, are you guys open? Following along now?
I've got them up.
Okay. So in drawing 8, you can see this is, I'm probably going to recover some old material or some stuff I just said, but this is basically the same setup as we have in our panel, where we have an external power source that's 120 AC. And so this power distribution is similar. It's for a similar panel installation to the one we've designed and built for this class. So it's showing the, oh, dude, come on. Sam, can you mute? You got dogs in the background.
Your microphone?
So you can see there's a neutral leg and a live and a ground all coming in, and it's from, so it says customer supplied because these were going to a customer site where they were going to be installed, and the customer was responsible for actually terminating this power into the panel. And so it says, you know, it details the power, and it details the power distribution panel where it's fed from, and then it shows the wire size. So because it's 20 amp and this panel drew a bunch of current, we specified that these wires that they brought in should be 14 gauge. We show there's a main disconnect on this panel for the power. So this was a giant physical switch. We just have a breaker in our panel, which is shown by this symbol here for circuit breaker. But similar concept. You want a single disconnect point that kills power to your entire panel. So so you can shut that off easily if there's a dangerous situation and sparks are flying. Real quick, I should have said this from the get-go. What we're going to be looking at is how to do drawing sets for a PLC control panel. And so that's going to cover, the first thing that's going to cover is just simple power distribution for the 120 AC coming in. It's going to go to a power supply that transforms that 120 AC into 24 volt DC, and then distributes it to all your 24 volt power, 24 volt modules. There's also going to be a decent number of modules in there that take 120 AC. And so we already have this panel designed and built, but because of time constraints last quarter, we actually didn't fully finish the drawing set. And so there's going to be some updates. What I'm going to cover today is just kind of an overview of what a panel set like that would look like, at least as far as we can in the time we have. And so this particular panel had a huge power, what do you call that, UPS, uninterrupted power supply. So that was just hooked straight onto the main power input. And then from there, it went to another circuit breaker and then started distributing power. And I think in the case of this panel, everything was 24 volts. And so the only things we had running off 120 AC were two 24 volt power supplies. Sorry, I take that back, a 48 volt and a 24 volt. Yeah. So you can see here, the power comes into this UPS, goes out to terminal blocks and to fuse blocks. And then from those fuse blocks, it goes into the power supplies. And you see here, this says jumper bar. And so a jumper is just a short wire or strip of metal that you use to create a common circuit between modules. And so when you're building a panel like this, it makes it really, really nice and easy, because what you can do is stick all your components together on a rail, and then you stick a jumper bar in between those, and it quickly connects all those in a circuit without having to run individual wires between every single one. And so when we built our panel, there were a few things where we didn't have the right size jumpers, and we had to manually create jumper wires, and it was a pain in the butt. And you'll see that later when we go through the panel. Okay, so in this drawing, we're showing this is 120 coming into these power supplies. And then we have 48 volts leaving this power supply and going into an arrow. And this arrow is calling out the line number and drawing number where this power is going. And you'll see here also the 120 AC was red and white. And you can see that L1 layer, they're not calling it 120, but you're supposed to know that L1 is this incoming line 120 AC. And then the purple is 48 volts positive. Pink is 48 volts negative. And you'll see the same thing down here with your blue 24 volt positive and negative, and teal is negative. The other thing I want you to note here is that off the power supply, there's just this little ground symbol. This is just symbolizing that there's a ground wire going to a ground lug, but you don't typically show very complex circuitry for ground wire. You're just showing that it is going to a ground. The other notes on the grounding is that you're bringing in a ground wire from your power distribution panel. There's a stud on the panel that's ground to. So it calls out the panel stud. And then on the door of the panel that swings out, there's another stud. And so what you do is you bring this wire into a ground block, and then run a wire to the door stud, and then run a wire to the panel stud, and then run a wire to the door stud. And what that does is it gives what's called a chassis ground through the whole panel, so that if you short anywhere on the panel, it grounds back to that main electrical panel and doesn't create an electrically live panel that somebody might shock themselves on. Okay, the last thing I want to note on this drawing, you see down the left side here, there's all these numbers, right, that are sequential. And then if you look, this is a 006. If you look, the first wire that starts in this panel has a label 0060. And then if you look down 2 more rows, 008, there's a 0080 and a 0081. And so the wire labeling convention showed here is that you take the line that this number is on and you add a digit. And so the first digit you add is a 0. And then the next wire, so that wire label is 0060. And then the next wire that's on that line from left to right is 0061, right? And if there were another wire over here that were unique to this panel, it would be 0062. Now note that because this wire here, this L2 wire, originates outside of the panel, it's not labeled using that convention, it's labeled L2, whatever that leg is. So one of the things you got to do when you're creating a drawing set is make sure you start a numbered index on your first page that actually has wires, and then keep that going. And every subsequent page, you got to start up your numbering on the last number, or the next number after the last number on the previous page. And so this one ends in 29, so your next number would be 30, and so on and so forth. So this is something we didn't do in our drawing set for our panel that we need to go back and add so that we can then go label all our wires in the panel, because we ran out of time. And it's a huge problem because when you're trying to wire trace and figure out what's going where, all your wires are the same color. And so you have to actually physically trace it out, and it's a huge pain. Okay, so I want to show this convention. So this is calling out drawing 9 in the set. So hopefully you have that open. If you go to drawing 9, you can see here, it calls out the power type. It calls out the line it's coming from. So if you go back to drawing 8 and you go over here, oh, that's line 15. Cool. I'm just going to extend that out so you can see it. See, that's coming from line 15. So it turns out they weren't lying. And it's coming from drawing 8. So basically what you're doing is you're connecting those 2 arrows between drawings. Okay. And then I'm coming in. Here I can see this, based on this line number, this wire label makes sense. And then on the other side of this junction, I have a new wire number that corresponds to this number here. And then the same thing on the other side. And this is just powering a module that needed 48 volts. So we literally had an entire power supply in that panel that just powered this one module, because for whatever reason it had to be 48 volts. Okay. And then if you look here, same deal, 24 volts going out, going to line 59 on drawing 10. Go to drawing 10, boom, line 59. Whoa, that's funky. Something happened to that text. That's weird. Okay, line 59 coming in, and then you can see this is significantly more complicated power distribution, which is fine. So on here we have a bunch of modules. So there's the network switch, there's the case fan on the actual enclosure, there's the HMI touchscreen, and there's the PLC for the control system. Wow, we're starting to run short on time. Okay, so what I want to do is create a quick practice set of drawings, just a little 2-drawing set. So in our border, you'll notice we don't have a numbered index, so that's no bueno. So what I want you to do, open that drawing border file if you don't already have it open. So what I want you to do is go into the number 8, and we're going to just steal this drawing index because it starts at 1, and we want that for our first drawing. Okay, and this is the only case where I'm actually going to tell you to use Control C and then go over here and use Control V. Okay, cool. So we got that in our drawing. We got a couple extra things that we don't need. I'll delete those. Make sure you get the full numbered index. If you grab some extra stuff, it's okay. You can just delete it over in here. Okay, so now what I need to do is scale this to match my border drawing. So I'll select all of that and then type move, tag the upper left corner, and connect that to the upper right corner of my drawing or my border file. Okay, and then I need to grab that again. Make sure you don't get content from your border. Okay, select all of that and then type scale. Okay, and select the base point as this corner that we dropped over here. Okay, and then if you remember when we did this last time, you can drag and drop, or you can specify a reference scale. So we want to do reference. So once you've typed scale, type R and enter, right? And that tells it that you want to do it by reference. Okay, your first reference point is going to be that upper left corner again. Your next reference point is going to be the bottom left corner down here. So you can see that right there. Select that. And then your new length point, you're just going to drag down and match that bottom right corner of your border drawing. Okay. And so now the nice thing about using scale is it actually resized the text, stretched it out a little bit. So now what we can do is move that text over. So I'm going to type move, and then I'll select the bottom left corner of this rectangle. Go. Hey, sorry. What was the last thing you guys saw?
We were rescaling the number
Okay.
things.
Okay, so let me go back through that. Okay, so I'm going to select all this mess. Okay, and only this mess, not anything from the drawing, because I want to keep.
We can't see your screen.
Oh, yeah. This is a new technology difficulty we're having, guys. It's new and exciting challenges every time. Chances to grow as people. I don't know what's happening to my internet. I apologize. Okay, so you want to select that entire numbered index and the box that came with it. Okay, type scale. Okay, and then your base point that you want to specify is the top left corner. Okay, so if you remember what we covered last time in scaling, you can scale by reference, and that's what we want to do here, because we know exactly we want the scale to match exactly the border that we have already. So we're going to type R, enter. Okay, and then we need to specify the reference length, right, which is your starting length of your object you want to scale. So that's going to be the top left corner to the bottom left corner. Okay, and the last thing we have to specify is the new scale length, and that's going to be the length to the bottom right corner of our border drawing. And so when you click on that, bam, done. And this is one of those operations that eventually you'll hopefully get really quick at, because you're going to use it all the time. Because it's going to be very rare where you have drawings that are on the same scale and you can just quickly you can just directly copy content. So you always want to make sure you're working on the right scale, and unfortunately that just means manually rescaling, but you'll get really quick at it, hopefully. Okay, so now you can delete that reference box that came with your index. You can select your index, and then you can move it. So type move, and then reference off the bottom right corner of your border drawing. And you're going to move it over here to this corner that's the bottom of the drawing, and also the side scale index. Right there. Okay. So now we have a numbered index down the side. And that's what we need to assign wiring numbers. Okay. Now select that entire thing. And this is the only other time I'm going to say use Control-C, Control-V. Copy that over. Now, we're not going to do it here, but if you're creating this drawing set from scratch, you're actually going to have to go in here and manually retype all these numbers. I don't really know of a way to do it quickly. I'm sure there is. But yeah, you're just going to have to start numbering at 30 and go down. I mean, I guess the other alternative is you can go through that same, steal this index, go through that same operation to get that numbered index in here. But that's if you have an existing index to drawing set to steal from. So the point I'm trying to make is that operation we just did is much faster than manually going in and typing out all these index numbers and making sure that the space between each one is the same. So if you can, always try to cannibalize content from existing drawings, because it'll save you a lot of time. Okay. Now,
so what if we don't need 30 wires? Do we still have to go all the way to 30 or 29?
Yeah, so again, this is going to be your set convention, whoever you're working for. They should have existing drawing sets, right? And so this might be a panel shop, this might be a site standard, whatever standard you follow is sort of going to be dictated by someone other than you. And even for PLC drawings, like in this actual example set, this MPL set that we're using, later on down the road, because of the module spacing and stuff, they actually used a bigger index. So let me see if I can find that real quick to show you. One second. Yeah, so like here. It's locked up. Okay, so here you can see the index is actually not evenly spaced. And it's because of the way that the terminal blocks on the far right, sorry about the zooming in. Okay, so you can see here the terminal blocks on the far right, just the way they drew them. There's two of them together, two of them together, two of them together. And so there's a reason they drew them that way. That has to do with the physical layout of the hardware. But you can see on the left side here, the index goes, you know, two together and then skips a gap, two together. And then that corresponds also fairly well to this, this output module and the termination points on that output module. So it depends on the convention you're working under, and it depends on your actual physical hardware. And you may be making these decisions on your own based on the hardware you have. So there's no single set answer on how to do this. I would say 30 lines is a pretty good rule of thumb to work off of. So trying to think, because we're running out of time here. Grab that content and drag it out of the way. And then we're gonna draw. So we're gonna recreate that that power distribution style. Oh, one other thing I wanted to fix. This rev block being up here is problematic for electrical drawings because you often have content coming down from the top here. So we're gonna just grab that and move it. Move from the bottom left corner. And just move it down here next to the drawing title. And then, yeah, because we did that, we need to get rid of this drawing and recopy it. So delete that second drawing and just copy it again. And then zoom in down to this right here. You know, actually, you can just leave that. Change the drawing title to drawing 1. And then the DWG number, change that to 1. And then on the other title block, change this. By the way, I'm just double clicking on the text to open it for editing. Drawing 2, DWG number 2. And then down in the sheet number, change this one to sheet 2 of 2. And change this to sheet 1 of 2. Okay. There are ways to do automated self-filling drawing borders, and I've never been able to get it to work very well. It's usually more headache than even just doing it manually. Manually updating the title blocks is not fun either, but it's a necessary evil because you gotta have correctly named your drawings. So that's something you want to do as soon as you create a new drawing, is update at least the title and drawing number. And then as far as the sheet number, you want to kind of have a pretty good idea of the number of sheets from the beginning, and you want to throw in some spares into your set spaced intermittently, just in case you have to add more drawings, because if you don't put in spares and you have to insert a drawing in the middle of the set, or even at the end of the set, now you got to go through and renumber all the sheet X of Y, right? So always make sure you leave in spare drawings in your set. And there's at least one spare drawing in those example files that you downloaded. Okay, so real quick, let's draw some incoming power. So I'm going to say line. I'm going to make it come down from just below the border of my drawing. I'm going to make it come down pretty much parallel with line 1. Make it come across. I'm just going to decide to make it stop here. Okay. All right, now I want to mirror that on the other side of the drawing. So there's a couple ways I could do that. But the way I'm going to do it is with the mirror command. So I'm going to select that, type mirror. And then I know, because there's 8 of these cells, that the middle of the drawing is going to be right here. So at this junction, so I'll select that midpoint, move my mouse down, and voila. It recreated that on the other side. Perfect. Oh, I always screw this up. Okay, so mirror it, select my mirroring line, And then I always forget that it asks you if you want to erase the source object. No, I don't want to get rid of that. So then in between those, I want to draw a rectangle. Actually, you know what? No. This is incoming power, so I actually made those too long, but that's okay. So go to drawing 8 again, grab that circuit breaker and copy it over. The content's a little small, but it's okay. Okay, so I want to drag this wire to be shorter, grab this content and move it. And I want to grab the edge of this little circle right here. So you're gonna need quadrant object snap on in order to do that. And it'll let you grab the quadrants of a circle. You can see there. So grab that left quadrant, snap her on that line. Okay. Now I need another line coming off of that. Okay. So I want to make that line long enough to where I have spacing to add my labeling, but I'm not chewing up too much drawing. Okay. Then I'm going to go back over here to drawing 8, and I'm going to steal the content for this fuse block. And I want to make sure I get these little diagonal lines. So copy all that over. Okay. Now I am saving those diagonal lines for later. So drop them in there and then select everything but those diagonal lines and move it. Okay. So I got that. Now looking here, I need to relabel this. So this needs to be 0010. This needs to be 0011. Okay. And then now I want to make sure my line spacing is accurate, and I want to leave enough room for labeling and everything. So on this power distribution drawing, I'm going to say I'm going to leave 1, 2, I'm going to skip 2 lines for every for every entry I make, basically. Okay, so I'm just going to draw a reference line going from the middle of this circle to the middle of this, not circle 0. Okay, so now I have a reference line to use. Grab that, drag it out of the way, and then I'm going to move that. You'll see where I'm going with this in just a minute. So I'm going to grab that reference line, move it to the middle of this fuse, and now I can copy this fuse. So type copy. So select the fuse, also select your reference line, type copy. Okay, and then I'm going to make my copy reference point the top of this line. And then I'm going to go down here and I'm going to copy that onto the end of that reference line. So now I have a second fuse and it's spaced perfectly to be on that line, that 004 line. Got a chat here. Oh, we're over time. Okay, save this drawing. On Monday, we're going to keep working on this instead of doing a fresh set of lecture. So everybody that's got a split, go right ahead. I'm going to stop here and open the floor for questions.
What number did you label the wires again? I missed that part.
Okay, so this is an incoming wire from who God knows where. So we're just going to leave that as 1L1. But then the first wire in our panel starts on line 001. So I'm going to label it 001 and then add a digit on the end. And so the first digit you add is 0. So this is the first wire on this line in our panel. And so it starts as 0. And then the next line over here, which doesn't exist yet, so I'll just throw that on so you can see it, is going to be 001, and then it's the next digit, which is 1, right? And then this line over here is ultimately going to be 0012. Does that convention make sense?
Yes, thank you.
Sure thing. So the reason I copied the reference line here is that I can go ahead and keep doing that same copy operation all the way down the page, and it'll stay in that reference configuration. Any other questions? Awesome. Sorry this one went a little slow. I don't know what's going on with my internet, but we lost some time because of that. That's the first time that's happened out here. So hopefully I just need to reboot my computer or something and that doesn't keep happening. But I apologize for the cutoff. And like I said, we'll just continue this on Monday. So hopefully you guys are chugging along on that homework assignment. Feel free to email me with any questions if you're having any other issues. But I look forward to seeing you on Monday.